So as I said before, this is the first in a mini series of talks I'm going to be giving to the Wayne Library. I'm calling this episode 1, a photographic journey through the Terran solar system and beyond. As I mentioned during my intro, my name is Mike Green. I'm a solar system ambassador volunteer for NASA. This is one of my many talks I've been giving for the Wayne Library, and today's date, of course, is March 4th, 2021. Just so people know, the Ambassadors Program is a real thing. It is funded by the National Aeronautics and Space Administration. It's managed by the Jet Propulsion Laboratory in Pasadena, California, the folks who just landed the Perseverance rover on Mars. And it's a volunteer public program. We have volunteers from across the United States that speak on NASA's missions of discovery to various schools, civic groups, libraries, museums, planetariums, and so on. There are approximately 1,000 ambassadors nationwide. And since the creation of the Ambassadors Program in 1997, we have reached more than 10 million people directly and almost 500 million people indirectly. And I think that speaks very well of the program and the acceptance that the public has for it. So I usually start this talk with this picture. I call it a universe of galaxies. This is a picture taken by the Hubble Space Telescope in the early 2000s. It was on their advanced camera for surveys. It's called the Hubble Ultra Deep Field. The picture you see here is a part of the sky in the constellation Fornax, which is in the southern sky, which ground-based telescopes showed to be fairly empty. A few stars, a few galaxies, but nothing major. When the Hubble viewed it using its advanced camera for surveys, the upgraded one that astronauts had added to it since its original launch, it looked back and took this picture. This is over the course of about 1 million seconds, over about 40 Earth orbits, looking at exactly the 400 Earth orbits, looking at exactly the same patch of sky, which is basically only this big, if you really want to measure it. And what it found was, in this one picture alone, over 10,000 galaxies. Very few of these dots of light are stars. 99% of them are galaxies. And there's 10,000 of them just in this one photo. So you can imagine how many more there are in the entire universe. But not only does this picture show an enormous number of galaxies themselves, it's looking back in time. The light from these galaxies is taken hundreds of thousands or millions or billions of years to get here. Hubble's just looking at it now. So the ones that are in the forefront, that are more well-defined, these spiral galaxies you see here, are fairly close to the Earth, and their light reached us in about a few 100,000 or a few million years, which is a blink of the eye in the galactic sense. But if you look at the smaller dots here, especially the little tiny red ones, which really don't show up on the screen, these go back to almost 13 billion years ago. The oldest one, which you cannot see in this particular picture, but it is there, I promise you, goes back over 13 billion years, almost to the birth of the galaxy, of the universe itself, just a few million years after the Big Bang occurred. So when we see pictures like this, we're not just looking at pretty dots of light. We're looking back into time and into space. And I am having a little trouble advancing my slides right now, which I don't understand. Okay. Here we go. So It looks like I'm having some technical issues, but we're going to get through them, so please bear with me. But this is our home galaxy. This is the Milky Way, and this is where we are right over here. I'm going to have to use my pointer here. This is where the Milky Way, this is the Milky Way galaxy. This is where our solar system, the Terran solar system, is in the Sagittarius arm of the Milky Way. And this is what our solar system looks like right now. If my pen works again, and I hope it does, going from the sun, Mercury, Venus, Earth, Mars, the asteroid belt, which contains 2 dwarf planets, Jupiter, Saturn, Uranus, and Neptune, dwarf planet Pluto and its moon Charon, and some Kuiper belt objects which are out here. And if you remember from last summer, we had a little visitor from the Oort cloud, and that's the comet Neowise. So we're going to begin our tour of our solar system with, of course, the star, the literal star of our system, and that is the sun. Some interesting facts about our star. The sun accounts for almost 100% of the mass of the solar system. Over 1 million Earths could fit inside of the sun. Unfortunately, one day the sun will consume the Earth. It's still a few billion years away, so I wouldn't lose any sleep over it right now. The energy created by the sun's core is nuclear fusion, and that's something that we're still trying to work on here on Earth. The way we obtain atomic energy currently is through nuclear fission, which is very, very dangerous. If we can solve the fusion problem, that could give us unlimited energy going forward. And the sun is almost a perfect sphere. We've sent several probes into this solar area, but the most recent one that the United States has launched is called the Parker Solar Probe. And it's doing a phenomenal job of get closer and closer to the sun right now. It's actually, as we see here, a mission to touch the sun. The probe was originally named Solar Probe Plus, but a few years ago, NASA decided to honor the father of modern heliophysics, Dr. Eugene Parker. This is Dr. Parker looking at his prior to its launch. Dr. Parker is still alive. He'll turn 94 in June. And he was the first living person to ever have a spacecraft named after him. This was the launch in August of 2018 of the Parker Solar Probe on a Titan IV heavy launch vehicle out of Cape Canaveral, Florida. And correction, that's the Delta IV Heavy, not the Titan. Titan's been retired. That's the Delta IV Heavy. At the time, it was the most powerful launch vehicle in the United States inventory. It has now been surpassed by the SpaceX Falcon Heavy. And these are some pictures that the Parker probe has taken on its voyages into the sun. While it won't physically touch the surface, it will get close enough to the corona. It'll fly inside the corona of the sun, where we think some material from the surface is ejected. And when they say a mission to touch the sun, Parker will get within 4 million miles of the sun's surface, but it'll be inside the corona, and we'll actually be able to discern some of the physical solar material during its passes. And on its way, it has done phenomenal job so far. This is a picture it took on its first close pass of the sun. The little object you see here, this is the planet Mercury. It took as it was getting closer to the corona. These little other dots over here are just corrections in the picture itself. But that actually is Mercury, that white dot there. Just a few weeks ago, the Parker probe took a family portrait of some of the planets of the solar system, looking outward from the solar area. And while they don't seem to be entirely in order, it does show Mercury and Venus, Earth, Mars, Jupiter, and Saturn. So that's a really, really nice picture that was just taken. This is brand new. It was only released about a week or two ago. We move on to the first planet of our solar system, which is Mercury. There's some interesting facts about Mercury. A year is only 88 days long. It is the smallest planet of our solar system. It's the second densest planet. It does have wrinkles. And when you're about 4 billion years old or so, we all do. It does have a molten core, not as dynamic as the one here on Earth, but it does have a core, a molten core. It's the second hottest planet in the solar system, even though it's the one closest to the sun. It is the second hottest, and it's the most cratered planet in the solar system. These are two American spacecraft that have done extensive visits to and imaging of Mercury. Mariner 10, which was the first American spacecraft to venture to Mercury, and the Messenger spacecraft, which spent many years orbiting the planet, sending back some amazing pictures of the surface. One way people get to see Mercury is in a transit. When it does, it goes across the face of the sun. This is over a period of time. It happens every few years. It's not a common occurrence, but when it does, it's usually broadcast on some kind of a slew broadcast on the internet, and it is very interesting to see. This is a topographical map based in different colors of Mercury's surface, ranging from the highest elevations, which are white, which you can see in areas over here and here, to the darker color blue areas, which are the lower points, usually impact craters. And these are other false color images of the planet itself. You can see the wrinkled surface, as we said before. You can see the vast amounts of cratering which takes place. The various lines over here that shows those wrinkles and scarps and other geological phenomenon. And these are some pictures taken from orbit, black and white, but it does show how Mercury looks like the moon more than any other planet in the solar system that we're aware of. You can see the extensive cratering over here. And I like this picture because it shows some of the major impact areas that look almost like the lunar crater Copernicus. But you can see the lines radiating from the impact sites. And these false color images up here, which show the different craters in their central peaks that you can see there, and they're definitely the result of meteorite impacts. Following Mercury, we move on to the second planet in the system, which is Venus. And Venus is the hottest planet in the solar system, with an average surface temp of about 880 degrees Fahrenheit, hot enough to melt lead. And the reason Venus is hotter than Mercury is the fact it has that very thick greenhouse type atmosphere, which traps the heat. Mercury does not have an atmosphere, so its heat is radiated away. Venus keeps the heat by its surface, so that does make it the hottest planet in the solar system. 1 day on Venus equals about 243 Earth days, and the day actually lasts longer than an Earth year. It rotates in the opposite direction, called retrograde, than the other planets do. It's the second brightest object in the night sky, particularly when it's close to Earth. It looks like a jewel up in the sky. Only the sun and the moon are brighter. The atmospheric pressure is 92 times greater than Earth. So I don't think we'll ever have any human landings on the planet. It would just crush any being or machine that we send down there. The atmosphere is mainly carbon dioxide with clouds of sulfuric acid, not the most inviting place to live or work. And Venus has more volcanoes, or we'll call them dormant volcanoes, than any other body in the solar system. These are some of the spacecraft, American spacecraft, that have visited Venus in the past. Mariner 2, that you see over here, was the very first interplanetary spacecraft launched by the United States. In 1962, it flew by Venus and returned the first close-up data of the planet itself. And that was followed by the Pioneer Venus mission and the Magellan mission, which is actually deployed from the Space Shuttle Atlantis on the STS-30 mission. As I showed you before, that transit of Mercury, this was a transit of Venus from a few years ago. And I actually watched it on TV, which shows what an exciting life I lead. It took a few hours for Venus to make the transit across the sun's face, but it was really kind of cool to watch it. So if you hear some of the future transits coming up of Venus or Mercury, while it does take some time, it is interesting to see it while it does occur. These are some pictures, this one, and this one, taken by the Soviet spacecraft Venera 13 that landed in 1982 on the surface. Did not last long. It was crushed under the pressures of the Venusian atmosphere, but it did take these first photos of the surface. This one is a true color picture. These other ones, this one and this one, were photo enhanced after the pictures were sent back in black and white. The Soviets enhanced them to give these colors of the surface. This is a picture kind of taken at an angle by Magellan using its radar mapping system. And you can see a very defined volcano there in that picture. And also some of the chaotic surface that you see here. This is also a radar image that was enhanced into a photograph. These are other pictures, black and white pictures, as discerned from the radar returns from the Magellan spacecraft. And you can see the different craters over here, impact craters. This looks like a dormant volcano over here, the caldera. Other pretty well-defined craters that were seen on the surface of our sister planet. This is a portion of the surface of Venus called the Aphrodite Terra. It would be the equivalent of one of our continents here on Earth, whereas Venus doesn't have liquid water on the surface. You don't have the sea level, you don't have the continents rising above, but these are some of the higher spots that are given the names of different terra. And in this case, the Aphrodite Terra is about the size of, say, of Africa. This entire region here, composed of impact craters, the different rill systems that you see here, almost look like flowing rivers, and perhaps they might have been lava flows in the past. But our old friend, the Parker Solar Probe, on its last visit to Venus as it looped around to gain a gravity assist on its next pass toward the sun, actually took this great picture of Venus showing the Aphrodite Terra right over here. It also revealed with this little bright band over here called night glow. It's ionized gases in its atmosphere that glow in the darkness. And all these little rays you see here are just cosmic rays, solar rays, that showed up on the time lapse of the picture when it was being taken. So I believe that takes care of our voyage to Venus, and now we move on to the Earth-Moon system, which is essentially a double planet. This is not to scale. The moon isn't that close in size really to the Earth, but it does look that way in this particular picture. Some interesting facts about our own home planet that you might not know. Earth is composed mainly of iron, oxygen, and silicon. It is the densest planet in the solar system, even though others are larger and maybe more compact. The combination of Earth's size and its mineral and chemical composition does make it the densest planet. Uh, of course, 70% of our planet is covered with water. We do have that molten iron core, which creates a magnetic field around the Earth, which protects us from the solar rays and cosmic radiation. You may not have known this. While we do have one major moon, we have two co-orbital satellites. They're wayward asteroids that have taken up residence in our neighborhood. And while they don't circle the Earth as the moon does in a regular orbit, they're both on the outside, kind of looking in, and they have their own little particular perturbed orbits, but they pretty much stay in our neighborhood. So they're kind of trailing us as we voyage around the sun. We do have the geothermal plate tectonics that keep our planet comfortable, avoids the runaway greenhouse effect that we do see on Venus right now. And still, so far, we're the only planet known to have life, though there are other candidates out there that we're hoping might pay off in the future. Right now, Earth is the only place that actually has an active biology that we're aware of. Moving on to our companion on our voyage, the moon. Some interesting facts about our neighbor. Uh, we say there's the bright side and the dark side. Well, there is no dark side of the moon. That is a myth. There is a far side, and it gets the same amount of sunlight as the front side does. But because the moon is tidally locked in orbit around the Earth, you only see the one face. But you see the moon for a 2-week period from it goes from a small crescent to the full moon and then back to a crescent again before it disappears. That time is called the new moon, and that is when sunlight abounds on the far side. Now, the Chinese actually have a rover on the far side of the moon, taking some fabulous pictures right now. It's been up there for about 2 years. The moon is responsible for the falling and rising of the tides on Earth. It is drifting away. And the moon is retreating from the Earth at about 1.5 inches per year, and it will continue doing that forever. It is not coming back. Eventually, it will just leave our neighborhood completely. 12 people have walked on the moon, all American males, but hopefully within the next 3 or 4 years, that might also change. The moon is airless. There is no atmosphere, but it does have quakes, both generated internally and by impacts of asteroids and meteors on the surface. These are just some pictures. I thought it looked kind of nice, particularly this one, which show the Earth and Moon together. This is a very famous picture over here taken by astronaut William Anders on the Apollo 8 mission in 1968, which was the first human flight to orbit the moon. This is called Earthrise. And I kind of like this photo also. The moon is kind of small here. It's taken from the International Space Station. But I want you to look at this, the very thin blue line here, which is our atmosphere, because I want to show you something a little bit later in my presentation that looks kind of similar. Of course, we have had our astronauts on the moon, and right now this is something I think everybody remembers, and if you don't, I'm going to play it for you again. The first human step on the moon by Neil Armstrong on July 20th, 1969. I still get chills watching that. It was just a remarkable, remarkable night. Uh, we've landed 6 different expeditions on the moon. Apollo missions 11, 12, 14, 15, 16, and 17. These are pictures from the Lunar Reconnaissance Orbiter, which is orbiting the moon right now, showing the actual landing sites of each of the Apollo missions. You can clearly see where the lunar module descent stages are, where the footprints, or in some cases later on, the tire tracks from the lunar rovers worked on the surface. There's a LEM over there, there's a LEM over there. So when people say we have no evidence of humans being on the moon, these pictures from the Lunar Reconnaissance Orbiter kind of prove that we were. But of course, any picture could be doctored. So for those deniers who are out there, the truthers, conspiracy theorists, they will not accept the fact that the evidence is crystal clear that humans did land, did walk on the moon. And there's some people that you just can't convince otherwise. But I think this is fairly conclusive evidence that we were there. One really interesting nugget, on Apollo 14, this was Alan Shepard and Ed Mitchell on the surface, Stu Rusa in the Apollo command module. They brought back a rock called Big Bertha. It weighed about 20 pounds. This is a picture of Big Bertha here. When it was returned to Earth, scientists did an analysis of it and discovered that there was a small portion of Big Bertha called the felsite clast, which was over here. The entire rock itself was a breccia, which means it's composed of different types of rock material. This only happened 2 years ago. It was announced 2 years ago, but that felsite clast is actually arguably the oldest Earth rock ever found. Now, I want to repeat that. The oldest Earth rock ever found. And it was discovered on the moon at Fra Mauro Formation by the Apollo 14 astronauts. There's a very interesting backstory to it. I would get into it in more detail if I could, but I just don't have the time now, but I'll certainly be able to discuss it later if you'd like. So 1969, first step on the moon, Neil Armstrong. 1972, the final steps on the moon by astronaut Gene Cernan, commander of Apollo 17. So now we move on to our next step, which is Project Artemis. Artemis is our next human lunar program. People did not realize at the time, and I didn't know it till the program was announced, but Artemis was the twin of Apollo. She was the goddess of the moon in Greek mythology. And the reason we named the new project Artemis, which will put us back on the moon and then hopefully on to Mars, is that we hope to land the first woman and next man on the moon, dictated by the Trump administration by the end of 2024. That might be a bit delayed now under the new administration, but I do think within the next 5 years or so, we should have our next human cruise on the moon. This is the architecture for the first 3 Artemis missions. Artemis 1, which we still hope to launch an uncrewed flight by the end of this year, but probably now early 2022. It will be about a 3-week mission just to stress the new Artemis system, the Orion spacecraft, the launch vehicles, to make sure they can withstand long duration flights out of the Earth orbit, low Earth orbit, and into lunar space. Artemis 2 will be a human mission. It'll last about 10 days, not a landing, but again, to pilot an Orion spacecraft with 4 astronauts. That flight will be about 10 days and is currently targeted for 2023. And then eventually the Artemis 3 mission, which will be the last, the first human landing on the moon since 1972. It'll be a 4-person crew, but two of the astronauts will make the actual landing on the surface. Target right now is the lunar South Pole. This is the lunar South Pole Aitken Basin, which we know for a fact contains a lot of water ice, and water can become a valuable resource if you find a way to actually mine it and process it in the future. Water, you break into its components, hydrogen and oxygen for breathing. Hydrogen and oxygen also make excellent rocket fuel. If you can develop some kind of a usable, reusable way of using water as a resource, the moon becomes a very, very attractive place to launch missions to the outer solar system. So how do we get there, back to the moon? We go using this new American rocket called the Space Launch System, the SLS, which uses two 5-segment solid fuel shuttle-derived solid rocket boosters for upgraded RS-25 space shuttle main engines. It will generate 8.8 million pounds of thrust at liftoff, which is over 1 million pounds more than the great Saturn V did for the Apollo program. This is the Orion spacecraft, which will carry the crews from Earth orbit to the moon, into lunar orbit. It'll carry 4 astronauts at a time. This is the Lunar Orbital Gateway, which is a small space station that we've placed in what they call a rectilinear halo orbit around the moon. And don't make me explain it right now, because I'm not sure I understand it myself. But it will be the base from where the Orion spacecraft will dock. The lunar landers will be docked there also. 2 astronauts will remain on board doing experiments while the other 2 go down to the surface. These are the 3 teams that are vying to build the next lunar landing system. The Dynetics team, of course, our friends at SpaceX, and the national team. NASA is supposed to decide by the end of next month. They want to decide on 2 contractors, 2 builders of lunar landers. So one of these guys will be eliminated, and 2 will get contracts for human landings toward the middle of this decade. Once a contractor is chosen for the lunar lander and the vehicle is built, the crews will land right now at the lunar South Pole. They will conduct their experiments on the surface, spend about a week right now is the time on the surface, as opposed to a maximum of 3 days, which the Apollo program had. And then they will pack up their experiments, launch back up to the Gateway, return to the Orion spacecraft. Orion will re-enter the Earth's atmosphere, very similar to the way Apollo did, at 25,000 miles an hour. Will land in the Atlantic or Pacific Oceans, depending upon the re-entry trajectory, under 3 huge parachutes, and will be recovered in the ocean by the United States Navy. These are the Project Artemis astronauts. A few months ago, NASA named 18 men and women. That will be the Artemis crew. 9 men, 9 women, some rookies, some veteran astronauts. 2 of them right now, Victor Glover and Katie Rubins, are actually on orbit right now on the International Space Station. While none of the Artemis crews have been named yet, and I have nothing to base this on except gut feeling, keep an eye on Annie McClain. For some reason, I just think she is going to be named the commander of Artemis 3. That's just me, but I just have a gut feeling she's going to be named to that landing mission. So that concludes my part on the Earth-Moon system. We move on to Mars, which has been in the news a lot lately. Facts about the red planet. Mars and Earth have approximately the same landmass. Even though Mars is smaller than the Earth, it does not have the oceans that Earth does. So our landmass is based upon our continents, which rise above sea level. And Mars landmass is its total total surface. Mars is home to the tallest known mountain in the solar system, Olympus Mons, and the largest known canyon in the solar system, the Mariner Valley, over here. Though we did find out recently that Olympus Mons might have a competitor as far as largest mountain. I'll talk about that in a little bit. Mars has the largest dust storms in the solar system, and while that might not seem important, it has delayed orbital observations from spacecraft that have been orbiting the planet because it totally obstructs a view of the surface, and actually killed off one of our rovers a few years ago. Pieces of Mars have fallen to Earth. This is the famous Allen Hills meteorite that was discovered in Antarctica in 1984. There are signs of liquid water on Mars called recurring slope lineae, which occurs on cliff faces and crater walls in the March and springtime. And one day Mars will have a ring as its large moon Phobos gets closer and closer to the surface. It will enter the Mars gravity well and be torn apart by Mars gravity. These are pictures of some American spacecraft that have flown to Mars. Mariner 4, which is the first American spacecraft to do a flyby of the planet in 1965. Pictures of Mariner 6 and 7, which were identical spacecraft, flew by Mars in 1969. This is Mariner 9, the first spacecraft to orbit Mars. Viking 1 and Viking 2, which were two-part systems, the orbiters and the landers. And this is Viking as it looked like on the surface of Mars. Other landers, stationary landers, InSight, which is on Mars and operating right now. Our first rover on Mars, called Sojourner, part of the Pathfinder mission in 1997. Spirit and Opportunity, the Mars exploration rovers, which discovered evidence of water on the surface, and Curiosity, which is still operating at Gale Crater right now. This is the very first picture ever taken of Mars by a remote probe. That was by Mariner 4 as it flew in over the western limb of the planet, moving eastward. You can see that some of the camera resolution was not great in 1965, but you were able to discern some surface features, and they can definitely see that the craters were there, which was a little disappointment. We were hoping Mars would be more Earth-like. It turned out to be more Moon-like. And as time went on, the photography improved to a great degree. So these are the Mariner 6 and 7 pictures, also in black and white, but you can definitely see distinct cratering on the surface. And again, photography got better. These were orbital pictures taken by Mariner 9 once the dust storm settled, and its first discovery of the Mariner Valley, which is the Grand Canyon of Mars. Only where the Grand Canyon here on Earth is a couple hundred miles long. This is about 3,000 miles long. It also showed evidence of rivers and streams and lakes, and these had to be water derived. These are not lava flows. These were created by water, flowing water on the surface, and discovered Olympus Mons, which we knew there was something there, but turned out to be the largest dormant volcano in the solar system, over 80,000 feet tall, 300 miles wide, basically the size of the state of Arizona. And then when the Vikings got there in 1976, again, they discovered more evidence of ancient river systems, as you can see here. Better picture of the Mariner Valley, color picture of Olympus Mons, and this guy. This was the face of Mars, which had the public buzzing when it was discovered by the Viking 1 orbiter in 1976. It does look like a human face, definitely with the eyes, the nose, and the mouth. But it was an optical illusion because further missions in the future showed it to be just a hill. This is it from another camera angle. It was just the angle of the sun at the time Viking was passing overhead that made it look like a human face. but this is actually what the face looks like in reality. And of course, we got our landers down, beginning with the Viking missions in 1976. This is the very first picture ever taken from the surface of Mars by Viking 1. This is the first picture from the surface by Viking 2. And you can see how the colors were consistently copper colored, reddish color. Some of the rocks and pebbles that were strewn on the surface. The horizon that we now know to be kind of a pink color. Really, really nice. And the Vikings were the first one, Viking 1, which landed on July 20th, 1976, and Viking 2, which landed on Labor Day of 1976. We did also have the Mars exploration rovers, Spirit and Opportunity, that drove across the surface of Mars in the early 2000s and lasted years and years and years. Their warranties were good for 90 days, and both of them made it to at least 2010 and even beyond that. One of the major findings were these little suckers over here, little chondrites or chondrules, nicknamed blueberries, which on Earth can only be formed in the presence of water. So within just a few weeks of their landing, both Spirit and Opportunity confirmed that their landing sites were once covered with water. Just some nice pictures of the horizons over here from both of the rovers. This is the Columbia Hills area, which was named in honor of the STS-107 crew of the Space Shuttle Columbia, which was destroyed on entry in 2003. Again, another picture of the blueberries over here, plus some drilling that was done by the rovers. And also from orbit, the great Mars Reconnaissance Orbiter, which continues to do a fabulous work for us since it arrived in orbit in Mars in 2006. Just some of the great pictures it has taken. This is a dust devil, a wind devil, small tornado that it photographed from orbit. Again, that recurring slope lanai showing possible evidence of flowing water inside the canyon walls on the planet. This is a fabulous picture. This is an avalanche, a landslide that MRO just happened to be flying over, and you can just see the dust that was raised from that event, from that avalanche. Just amazing. That the timing on it was just really, really impressive that I was able to get that picture. And this is another picture that MRO took of the Curiosity lander, about 2 minutes away from landing on Mars in 2012 under its supersonic parachute. And you'll see something very similar in a couple of seconds. This is a self-portrait that Curiosity took of itself in Gale Crater. And these are pictures of Curiosity has taken during its ride there. This is Mount Sharp, the 4-mile-high mountain that's in the center of Gale Crater. These rocks here could only have been formed in the presence of water. We know that. And Curiosity has proven again that there was water, at least in Gale Crater in the past. But if you look at some of these pictures, like this one, it looked like the southwest of the United States. And it looks like portions of Utah or Arizona, New Mexico. Very, very familiar, very comfortable. It's almost as if Mars is beckoning, saying, hey, come to us. We look just like your home. And of course, over the last week or so, we're all familiar with the Perseverance rover successfully landing on the surface. I'm not going to go into a lot of detail on Perseverance. It's still going through its checkouts before it can be commissioned for actual work on the surface. But these are just some of the first photographs that came in from Percy. Again, you can see where it landed at Jezero Crater, the crater walls over here, its landing system under its sky crane over here. some of the hills and mounds in the nearby landing site. And this picture, you might have heard this before, but that's its parachute as it was coming in toward landing. And in binary code, written right along here, are the words, "Dear Mighty Things." The people at JPL just put that little Easter egg in there for people to decipher once these pictures came through. And one thing that the people at NASA and the Jet Propulsion Laboratory and all the associated NASA field centers do, they do dear mighty things. New pictures from Perseverance from orbit. This is the one, again, another one from the Mars Reconnaissance Orbiter, showing Perseverance still in its aeroshell under its parachute about 2 minutes before landing. This is the landing site. That little dot there is Perseverance. And you can see where some of the hardware was discarded on the surface. This is Perseverance over here, but its heat shield was jettisoned. Its descent stage was over here. The parachute and back shell over here. And this picture right here shows actually after the impact of the descent stage blowing up a cloud of dust. That's about a mile away from the actual landing site. So we did not get a picture like that from Curiosity when it landed, but we did get this remarkable picture of the impact from Perseverance. So that finishes Mars for now. I'm going to run on to planets in the asteroid belt. They're now considered dwarf planets, Vesta and Ceres. These were visited both by the Dawn spacecraft. It was the first first probe to go to two different planetary bodies. Vesta was discovered in 1807, and it was named after the virgin goddess of home and hearth from Roman mythology. It's very bright, and it can occasionally be seen from Earth with a naked eye. I mentioned before that Olympus Mons, which we still consider the largest mountain in the solar system, does have something out there that could compare to it. And it is in the southern hemisphere in the Rhea Silvia Basin, where there was a giant impact and drove a central peak up to about 12 to 16 miles. Hasn't been accurately measured as yet, but it does compete with Olympus Mons as potentially the largest mountain in the solar system. Ceres was discovered in 1801. Once was considered a planet and then was reclassified as an asteroid. And then in 2006, when the International Astronomical Union changed everything, it was reclassified as a dwarf planet. And this bright area here had got everybody's attention as Dawn was coming in for its orbital mission. It turns out that it's a 3-mile-high mountain composed of salt and mud called Ahuna Mons. And it gave evidence that there is still some kind of an active geology on the surface or just below the surface of Ceres. That came from a cryovolcano, and we do believe there might be potential activity. You don't want to say potential life, biology, we don't know that for sure, but where there's water, there is life, and there's a chance something might be going on below the surface of Ceres. Moving out through the asteroid belt, we come to the king of the planets of our solar system, which is Jupiter. These are some interesting facts about Jupiter. We do believe it's a failed star, just didn't have quite enough mass to start the fusion process that would have lit it up. Every other planet in the solar system would fit inside of it. It takes 10 hours to rotate, but 12 years to orbit the sun. It has more than 60 moons. 4 were discovered by Galileo, and they are known as the Galilean satellites. And it's brighter than any of the other stars in the sky, and only Venus as another planet can be brighter. And a few months ago, there was the great conjunction with Jupiter and Saturn, and it was really blazing up there, if you remember that. These are some spacecraft that have visited Jupiter. Uh, the Pioneers, the Voyagers, Galileo, and still in operation right now, Juno. These are some pictures Juno has taken recently of Jupiter. You can see the northern aurora cap over there. Beautiful picture of the great red spot over here. The different vortices over here, the jet streams that occur through the Venus atmosphere. I'm sorry, through the Jovian atmosphere. Another great picture of the great red spot. And this is the southern pole, the southern polar region of Jupiter. These are the four main moons. Again, there are over 60, but these are the Galilean satellites, Io, which is the most active geological body in the solar system. Dozens and dozens of volcanoes constantly erupting. Europa over here, which we have pretty good evidence as a subterranean ocean in contact with a heat source. One of the prime spots for exobiology in the solar system. Ganymede, which we believe also has a subterranean ocean, and Callisto, which is one of the darkest objects in the solar system. We're looking at Europa particularly. This is not to scale, but this is a Hubble telescope image over here and here of the geysers erupting from the surface of Europa. There are fissures and cracks in the surface that allow the water, salt water, the briny water under the surface to escape. And you can see in the pictures here and here also of the active geysers on the surface, and give us great hope that there might be a chance for biology, active biology on that planet. I'm sorry, on that moon. And we're planning to go there in a few years to study it in more detail. Saturn, the most beautiful planet in our solar system, the ring giant. It's the least dense planet in the solar system. If you can get a bathtub that would fit Saturn, it's got to be really big. But if you can get into a bathtub, Saturn would float. It has currently 82 moons, which holds the record, but Jupiter, new moons are always being discovered, so Jupiter will probably catch up one of these days. This is a great statement. The rings could be very old or they could be young, depending upon the way people analyze the data coming in from the Cassini mission. And there could be life not on, but near Saturn. This is Cassini, which had a 13-year voyage through the Saturn system and made some amazing discoveries. The data still coming in, even though the spacecraft has been dormant, was intentionally destroyed in 2017. Some false color images of Saturn taken by Cassini, including this great picture over here. You can see it moving of the North Pole hexagon, which is a jet stream. The winds just fly around it, but it somehow, and we're still not sure why, but the jet stream forms this perfect hexagon in the sky. These are the major moons of Saturn, but the ones that we are most interested in, of course, Enceladus and Titan. And the reasons why, again, Enceladus, the active water jets, geysers that come out of its southern pole, and Titan, which is shrouded in a very nitrogen, methane-rich atmosphere, very similar to early Earth, and pictures taken not just from Cassini, but from the Huygens probe, which actually landed on Titan in the early 2000s, showing different mountains and river systems you can see here. This is from the surface itself, showing some ice balls, different types of rocks. This is an actual picture taken from the surface of Titan by the Huygens landing probe. Uranus, which looks just like a, a ball from if you're playing pool, not a lot detail to it. Uh, it was discovered in 1781. It does lie on its side. We think a collision probably contributed to that. It's the second least dense planet in the solar system after Saturn. But it's also the coldest planet in the solar system at minus 371 F. These are the major moons of Uranus, taken by the Voyager 2 probe as it passed by. And you can see the different ones here, but Titania, right over here, we believe has a subterranean ocean also, and that should be examined in the future. Uranus also has a ring system. Let me go back there for a second, if I may. So you can see some of the rings of Uranus over here. We do think that another probe to the outer planets, to both Uranus and Neptune, will be very useful, and they're already on the drawing boards for the mid 21st century. Neptune, which is now the furthest planet of the solar system since the demotion of Pluto. Neptune takes about 165 years to just orbit the sun. The second largest gravity of any planet in the solar system, following Jupiter. It has a storm system similar to the Great Red Spot. It's known as the Small Dark Spot. You're right there. It does have a ring system also and 14 known moons. And its moon Triton is the coldest known object, not just planet, but coldest known object in the solar system, with a surface temperature recorded at minus 391 degrees Fahrenheit. These are some of the moons of Neptune. Again, Triton, we do believe, has a subterranean ocean and should be investigated in the future, much in the way we're going to go back and look at Europa and Enceladus in the future. So Triton is definitely on that list for examination. And then we come to dwarf planet Pluto. Used to be the 9th planet, but in 2006 it was demoted to the title of dwarf planet. I still argue with that. It was discovered in 1930 by Clyde Tombaugh at the Lowell Observatory in Arizona. It was reclassified from planet to dwarf planet in 2006. I have a problem with that. It has 5 known moons. It's the largest of the dwarf planets, but there are many more dwarf planets now, as I showed you Vesta in series before. There's other ones out there in the Kuiper Belt. Pluto is 1/3 water. We didn't think water could exist that far out in the solar system, but it does. It has an eccentric and inclined orbit, which means if this is the orbital plane with Earth, Venus, Mars, Jupiter, Pluto is out here. So it's out of the ellipse. And sometimes it does have an active atmosphere. As I showed you earlier, that picture of Earth is taken from the International Space Station, showing that blue line, which was our atmosphere. Check this out. That's a backlit picture of Pluto, taken by the New Horizons probe when it passed by in 2015. And there it is, a beautiful blue atmosphere, not oxygen, not nitrogen, mainly methane, but it does show that there is an active atmosphere on Pluto. Pluto also has the beautiful heart over here, which is the Sputnik Planitia glacier field. There are cryovolcanoes, water-based, liquid-based volcanoes that come up through the surface. And because it is a smaller planet, low gravity, this red material here, which is basically called tholene, it's degraded methane. It actually can escape through from the surface into the atmosphere, and as it escapes the gravitational field of Pluto itself, it lands on the moon Charon. So these red objects, this red material here from Pluto is actually directed onto the surface of Charon also. You can see that like that. And there are other Kuiper Belt objects that are out there besides Pluto. These are now considered dwarf planets. Not sure if I pronounced them all correctly, but there's Quaoar, Sedna, Haumea, Makemake. Of course, Pluto is included in there, and Eris. And some of these have their own moons. As you can see here for Quaoar, its moon is called Wewat. For Haumea, it's Hayaka and Namika. These are some of the moons of Pluto. And Dysnomia is the primary moon of Eris. And these are all dwarf planets, all in the Pluto category right now. And then as New Horizons flew past Pluto, they were looking for another target out there. And they identified a Kuiper Belt object, which they named Arrokoth. And this is an actual picture that New Horizons took of Arrokoth out there on the edge of our solar system. Very interesting facts about it. It's been pretty much undisturbed for over 4 billion years. The two lobes right here came together in a very gentle collision. So they're very tenuous, being held together by a very, very small gravity field. No moons or rings, lightly cratered. You do see some cratering over here. Very little water on the surface. And then a few years ago, we received our first visitors from other systems called interstellar objects. And the first one we received was named Oumuamua, which means visitor from a strange land in Hawaiian. Oumuamua came through our system a few years ago from the direction of the constellation Lyra, but we really don't know exactly where it came from. It's headed out of the solar system. It will not be coming back. It did get a boost in speed from the sun, so the acceleration changed its original course from its earlier projections. NASA believes the Oumuamua is kind of tumbling as it flies, and it didn't kick off a lot of gas or dust as it went through the system, picking up any temperature increases from the sun as a comet would do. So we do consider it an interstellar asteroid. But then Oumuamua was shortly followed by interstellar object number 2, which was Borisov. And Borisov was an interstellar comet. It passed through our solar system. We originated in a binary star system called Kruger 60, about 13 light years away from Earth, which really isn't that far. It's an active comet. When it came through our system, the sun did light it up. It follows a hyperbolic path around our sun. It's moving at 110,000 miles per hour, which is pretty fast. So it doesn't care if the sun is there or not. And last year, the middle of last year, it passed the orbit of Jupiter, which is about 500 million miles away, and it's heading it back out into the solar system, out of the solar system to interstellar space, and it will not return here ever again. So that's the solar system as we know it right now, but planets have been discovered outside the system using various NASA spacecraft. This is the Kepler Space Telescope, which was launched in 2009, and it discovered several exoplanets and more candidates. Of course, these are not the actual pictures themselves. These are artists' impressions of what they believe the Kepler planets look like. But this is the very famous TRAPPIST-1 star system with several possible Earth-like planets over here discovered by Kepler. And Kepler was followed on by TESS. And the TESS mission has discovered other candidate planets, exoplanets out of the solar system. Again, these are artists' impressions of what they believe these look like. It first began observation of the southern sky and then went to observation of the northern sky. And this is the area that was examined by the TESS telescope. This bright band here is the Milky Way, but all this region here was observed looking for exoplanets, and many, many, many were discovered. In fact, so many were discovered, they came up with an index called the Earth Similarity Index, ESI, to give a name, give a number to some of the planets that Kepler and TESS have identified. So if Earth is, of course, a 1, Mars would be a 0.64, Neptune a 0.18, Jupiter a 0.112. But look at some of these targets that they found here. There's a 95, 0.90. So some of these are very, very close to Earth in similarity. We don't know about potentials for life, but we do see them to be relatively close to what Earth looks like now and what these other planets might look like when we actually get to see them, which hopefully we will do. This is an impression of the super Earth discovered by the TESS Space Telescope. It's GJ357d. We believe, based upon data, that it is very Earth-like, a little larger than Earth, but might have oceans and clouds and continents. So we're very fortunate that we will be able to possibly image it because of some of the future and current missions that NASA has on the books. Right now, we are returning samples from the asteroid Bennu on the OSIRIS-REx mission. These are pictures of the surface of Bennu that Rex took while it was orbiting. And this is when it actually grabbed the sample just a few months ago. And in a couple of weeks, it's going to fire its engines and return that sample to Earth. Perseverance and Ingenuity just landed on the surface. I'm not going to get into a lot of detail. I'm saving that for a future talk I'm going to be giving in May. But just a couple of pictures, which I really like, particularly this one, which they call Seal Rock, taken just last week by Perseverance. It looks like a seal on a rock. So I don't think they showed indication of actual life, but it's intriguing nonetheless. Europa Clipper, as I mentioned earlier, we know there's a briny saltwater ocean under the surface of Europa. The Europa Clipper will be launched in a few years. Will actually orbit Jupiter, but make repeated passes past Europa. We don't want to orbit Europa directly, and God forbid something should go wrong and it crashes onto the surface. So we'll be orbiting Jupiter, but intercepting Europa's orbit for about 40 times and doing a very, very close-in study of the surface of Europa, hopefully getting into the geyser plumes to actually taste some of the water that comes out of the geysers. So this is going to be a very, very exciting mission. We have a mission called DART, the Double Asteroid Redirection Test. What we're going to do, this is a planetary defense mission. The first time we're going to launch a planetary defense project. The DART spacecraft will actually fly out into the asteroid belt to the asteroid called Didymos, and it has a small moon called Dimorphos. And what DART's going to do is going to impact the small moon to see if it can either redirect the asteroid itself, there's any effect on it, and that would be the way potentially in the future, if we do see an asteroid coming in that could possibly impact the Earth. We don't want to go through what happened to the dinosaurs, of course. This might be the first way to protect the Earth using a gravitational effect of the destruction of a moon, of an asteroid. And many asteroids do have complementary moons. So this will be taking off in a couple of years, then we should know the results of this within 2 or 3 years. Lucy is a mission to the Trojan asteroids. You might not have heard of these before, but around Jupiter, there are 2 swarms of asteroids, one that flies in front of the planet and one that flies behind it. The Lucy mission will go to both sets of these Trojans, they're called the Trojan asteroids, to visit them, study them. We believe this is primordial material from the beginning of the solar system, locked into these orbits around Jupiter. And if we can get down there and examine them, it might give a great deal of information to the origin of the solar system itself. And that is definitely on the board, and it'll be launching in just a few years. Psyche will be a very interesting mission. It's a mission to a metal world in the asteroid belt. There is a object which is pure iron nickel. We believe this was the remains, the interior remains of what had been a protoplanet, where its outer crust and mantle have been blown away potentially from another impact, just leaving the metal core itself. This is very, very rare. We have an opportunity to send the Psyche mission to this object, which is named Psyche, to determine exactly what it is and how it originated. Nothing like this has ever been tried before. We don't have many opportunities to do it, but things have just come together right now, and Psyche is on the books and will be launching in just a few years also. And then we have a series of new space telescopes. These are the successors to Hubble. The James Webb Space Telescope, which is the primary telescope project that NASA has, scheduled still for launch on Halloween on October 31st, but I would not be surprised if there's a launch slippage. It's already several years behind the schedule, but we just want to make it right. If things do work out, Webb might be able to follow up on discoveries of TESS and Kepler and actually image the surfaces and atmospheres of some of those exoplanets that were discovered. The Nancy Grace Roman Space Telescope, which should have launched before, should have launched before Webb, is running a little behind. It will follow after the Webb telescope, but it will give a wider version of the sky. That's why it's called a wide field. And it will determine targets that will label the Webb telescope to focus in on. So we're getting the wide look by the Nancy Grace telescope, and then then Webb will be able to focus on these findings. And then a new one, which was just approved last year, called Spherix. It's going to be an infrared telescope, and it's got the longest name I can ever remember. The Spectrophotometer for the History of the Universe, the Epic of Reionization, and ICE's Explorer. They're going to have to rename that thing. I just cannot keep saying that. And then finally, a mission that I wish I could be around when it actually occurs. I don't think I'm going to make it, but it's called the Titan Dragonfly. And we are actually going to launch in a few years a nuclear-powered drone that will fly through the thick atmosphere of the Saturn moon Titan, make repeated flights into the atmosphere, land, do some surface experimentation, and fly off again. I just a little video here that I hope give you a little better idea of how Dragonfly will operate. It'll take about 2 hours from the top of the Titan atmosphere to when it will actually land. Titan's atmosphere is that thick, but once it's released from its aeroshell, it'll turn on its 4 engines, its 4 rotors, and begin flying to a landing site right now in the Shangri-La highlands of Titan. And there it will settle down and begin its scientific observations of the atmosphere, of the land, potentially some of the liquid on the surface, liquid methane, which we believe is there. And once it completes its findings in one place, it can fire up its engines again and fly off to another site. And it'll do this over repeated period of time. On behalf of the National Aeronautics and Space Administration, the Jet Propulsion Laboratory, and of course, the Solar System Ambassadors Program, I want to thank everybody for your attention. And if you have any questions, I'd be glad to address them right now.
That was wonderful, Mike. And now here is a question. Someone would like you to explain the Felsite clast in more detail.
4.2 billion years ago, Earth was still being formed, but the crust was getting pretty much intact. And it was impacted by a large comet, meteor, asteroid, which blew material off the surface. The Felsite clast was actually formed about 12 miles beneath the surface of the Earth at that time, about 4.2 billion years. The moon at that time was much closer than it is right now. It was only about 50 to 70,000 miles away. So it didn't require as much energy to get off the Earth and into the moon's gravity well. So the original rock that was the Felsite clast was blasted off the surface of the Earth, landed on the moon, and about 3.9 billion years ago, there was a major impact. We believe it was the creation of the Imbrium Basin, which is one of the largest basins on the moon itself, and it buried the Felsite clast. And then about 26 million years ago, there was another impact which brought it up to the surface. And because it's a breccia, the rock is a breccia, the entire rock, which is called Big Bertha, is not the Felsite clast. The Felsite clast is a small portion of the rock. But 50 years ago, last month, the Apollo 14 astronauts, Alan Shepard and Edgar Mitchell, were making a hike up Cone Crater. And Al Shepard saw this big rock just laying there by itself, much bigger than what NASA ever wanted to return. But for some reason, Al Shepard wanted to bring that back. And with the help from Ed Mitchell, they rolled it up their leg because it's kind of heavy, a 20-pounder, but it's much lighter, of course, on the moon. They did return it to Earth. And none of the Apollo 14 crew is alive today. They've all passed on. And the announcement of the Felsite clast being the oldest Earth rock ever found was only made 2 years ago. So the crew was not aware of this tremendous finding that they made. They just brought back what they thought was they called it a biggie, and they named it Big Bertha. But we learned so much more from that. And thanks to Alan Shepard and Ed Mitchell for deciding to pick up this big rock on the moon. On behalf of the National Aeronautics and Space Administration, the Jet Propulsion Laboratory, and of course, the Solar System Ambassadors Program, I want to thank everybody for your attention.